Good afternoon, everybody. We only two. Okay. How are you guys doing? Can you guys hear me? Brian, Tristan, and I must just apologize for starting late. I had another meeting that I was part of.
It's,
Late. Can you guys hear me?
yes, we can hear you, but it's fine that we started late. There's not a lot of people here as well.
Yeah, I see. I think the Friday sessions don't work well. And you see, it disadvantage those who wants to learn as well, because if the sessions are not effective, it means we can stop running the sessions, but it will disadvantage those who are attending. Anyway, welcome and thanks for being part of the Friday session. Today, since we didn't have a session last week because of the public holiday, I have relooked at the session plan and we have covered some of the work that we were supposed to do on the 25th during the tutorial session. And during the tutorial session as well, we covered the quadratic equation. So it means I'm not going to cover those two sessions. Today, I'm going to continue and do differentiation with you. And yeah, so it means all the topics that we were supposed to do, I will move them up. I will move them forward so that we are all on par, and then it will also give us time to do a lot of exam preparations before your exam. But I need to know what is your exam date, because I think the sessions were scheduled up until the 30th of October. If your exam is somewhere before then we will have to re-look at the content as well to structure it so that I should be able to support you in preparation to your exams as well. It's on the 4th of December. Whew. Okay, that's way before the festivity starts. Okay. But then it also gives us time then, at least. So we will have exam preparation. All right. If you have any questions, now is the time to ask. Otherwise, we will start with the QMI. You have anything to say to me or ask or a comment? And if you joined late, there is the attendance register link on the chat. Please make sure that you complete the attendance register and we can start with the session. We are going to look at differentiation. So in the beginning, we'll just look at the terminologies that we use when it comes to differentiation. And then later on, we start looking at how we apply those techniques by looking at the real questions and unpacking those. Then we'll have a break and then go and do more exercises. And most of the exercises, like usually, they come from your past exam paper or your tutorialets. So you should be able to practice more with those exercises. Okay, so let's look at differentiation. By the end of the session, before I forget, by the end of the session, you will learn how to apply the rules of differentiation. You will learn how to calculate marginal cost and how to calculate marginal profit. by using the differentiation method. What is differentiation? Previously, like when we were doing linear regression or the straight line, we looked at the slope tells you how steep or how different your graphs is. Is it a negative slope? Does it go down? Or is it a positive slope? Does it go up? So it means one price, when if we're looking at the prices and the quantity, it says if your prices go up, does your quantity also go up or does it go down? And when we use the slope, we actually can see the difference that comes, or the relationship between the two numerical values that are there. So with differentiation as well, we can use it to look at the slope of the information that is given. So in this instance, we will be given a function which we can differentiate in order for us to find the slope of that function. And that's all what differentiation is all about. So when we differentiate, because we are differentiating a function, normally in a mathematical function, we use dy dx, which is the function of differentiating the value of your function, your function x. And to differentiate, we have some basic rules that we apply. And these are the rules that you're going to follow until the end, because if you know these rules, they are very basic. If you understand those rules, you will understand how to differentiate if they give you a different kind of a question as well. And you only differentiate once. So you don't do a differentiation on top of the differentiation. You're only going to do it once. And how do we then do this? We do this by saying, because we have a function, if your function has the power, it's a power function. So any number, you remember as well, going back to our session number 1, where we dealt with powers. Remember that we said any number, let's say we have a number, or let's say it's a variable. Sorry, I didn't want it to go to the next bit. So I just want to demonstrate what I am talking about right now. So if I have a function x, it is the same as to the power 1. And x is, if it's just an x, is the same as to the power 1. And x, we call it a whole term. So an x will become our whole term in terms of the differentiation, and the 1 will become our power. So with differentiation, we're going to multiply the whole term, which is our x, with whatever the value is in the power. That's what we're going to be doing. And the other thing that you also need to remember when you do differentiation is to also subtract 1 from the value that is in the power. How do we do this? Let's say we have a function, and this is the function that we want to differentiate. The function is y is equals to 4x to the power of 2. If you look at this function, our 4x is our whole term. 4x, even though it's multiplying, it's our whole term. And 2 is our power, because we differentiate in this function. And if we apply the rule that is set up, remember, we need to multiply by the whole term with the power. So we take the power, we're going to multiply 4x by 2, and we need to deduct 1 from the power. So we'll have to subtract 1 from this power. Do it in this way. 4 multiplied by 2, x to the power 2 minus 1, because we have to multiply by 2 and we have to subtract 1 from the power. And when we multiply 2 by 4, we get 8, and 2 minus 1 is 1. And we know any number with a power of 1, any number with the power of 1, can write it as that number. So x to the power of 1 will just be x. And that will be your differentiated function. The other thing I need to point out as well, when we differentiate a function, you don't have to use dy dx, you just use a y copy, and that will tell you that that function has been differentiated. The same way as with this function at the top, we use a copy to show that this is a differentiated function. Okay, this is just the basic rule, but there are other rules which you will have to understand before you start doing the differentiation of some of the functions. What am I referring to? And these rules are outlined clearly in your study guide as well. I'm just going to unpack them more so that you can understand them. So the first rule states to differentiate a constant. If A is a constant will be a number. So a constant will be numbers like 1, 2, 100, 400, 1,000, a million. All of them are called constant because those are just numbers. So to differentiate a number, the differentiated function will be equals to 0. So what do we mean by that? If we have a function, and remember in your book, they can write a function in different form. They can write it as f of x is equals to 2. That is still the same as y is equals to 2. It's one and the same thing. And we covered this when we were doing this linear regression and the systems of linear equations as well. That where you see fx is the same as a y variable. It's just, it says this is a function of x, which it means we can use x as a placeholder for any value that we can use to substitute into a function. And that f of x, which is a function, can be represented by a y letter, just one word or one letter, not word, one letter. So they mean one and the same thing. So going back to our differentiation rule, says if we differentiate a constant, is the same as 0. So it means if I'm going to differentiate this function, it will be equals to 0. That is all what the first rule is stating. The other rule, second rule, it states that, I've already did the example, I don't have to repeat it. So this one is the function of y is equals to 4, and if we differentiate it, it will be y hat is equals to 0. So the differentiated function will be equals to 0. Rule number 2, it says, if you need to differentiate the function y is equals to x to the power of n, is the same as what we applied in the basic rule that we were doing to introduce the concept. It says we're going to multiply by the value in the power, and we're going to subtract from the power. So the differentiated function will be n multiplied by x, n minus 1 in the power. So let's say I need to differentiate y to the power of x cubed. To differentiate y to the power of x cubed, I must multiply with what is in the power, which is 3, and I must subtract 1 from the power. So it will be 3 multiplied by 3 minus 1, which then becomes the differentiated function will be 3x to the power of 2. The next rule states that the following. It says, if I differentiate a constant times a function to the power of n, then the differentiated function will be to multiply the constant and the term or the function with n and to subtract 1 from the top. So we're going to multiply a times n x to the power n minus 1. In a practical example, if we have y is equal to 2 to the power x cubed, to differentiate this function, we multiply by 3, so it will be 2 times 3 times x. And we will have 3 to the power of x to the power of 3 minus 1. And 3 minus 1, so 2 times 3 is 6. 3 minus 1 is 2. And the differentiated function will be x to the power x. So 6 times x to the power of 2. The last rule, which is rule number 4, states the following. If we need to differentiate a sum of two functions, so if we are adding two functions, we need to differentiate them separately. So it means we're going to differentiate the first term or the first function and add to the differentiation of the second function. And when we do that, every function that we are differentiating, we're going to apply rule number 1 or rule number 3 or rule number 2. So to differentiate the first part we multiply by n and we subtract 1. And on this one, it's a constant times n times x, and we subtract 1 from the power. In a practical way, if we have this function, which is y is equals to x squared plus 2x to the power of 4, to differentiate this function, we multiply with what is in the power, which is 2, so it will be 2x, and we subtract 1. And we do the same on the other one. It will be 2 times 4 times x, and we subtract 1 from the power. 2x to the power of 1 will just be 2x plus 2 times 4 is 8. 3 to the power of 1 is 4 to the power, x to the power of 4 minus 1 will be x to the power of 3. And that is how you differentiate. Do you have any question at this point? Any question? If there are no questions, let me just check on the chat because I'm not looking at the chat right now. So no questions. Thank you. When we were doing the first session, I don't know how many of you were in that part of the first session. When we were dealing with powers, we spoke about the note on the power. And I said, you must pay attention to that note because by the time we come to the differentiation, that note will play a bigger role. And to refresh your mind, the note said, if A is any number, and this was when we were using the powers, if A is any number, A to the power of 0 is equals to 1, and 0 to the power of 0 will be 0. So any number to the power of 0 will be equals to 1. What do we mean by that? If I have 4, okay, like it was writing multiple times. If I have 4 to the power of 0, it will be equals to 1. If I have 10 to the power of 0, it will be equals to 1. If I have 1,000 to the power of 0, it will be equals to 1. That's what that statement means. Any number to the power of 0 is 1, except 0 to the power of 0 is same as 0. Any number without a power is the same as to the power of 1. I'm not going to repeat this because we did it previously when I was doing the first introduction. And any number to the power of a negative, remember we can write it as a fractional power. So what do we mean by this? If, for example, I have 2 to the power of minus 3, I can write this as 1 over 2 to the power of 3. And when I have the answer like this, remember this is numbers. So you can find the powers. And this will be 1 over 8. Because 2 times 2 times 2 equals to 8. And that's how you will solve this. You don't leave it as the power of a fraction like that. And vice versa. So you can also move from a power, a fractional power, so which is 1 over a to the power of n. You can move that into a power of a negative number. What do I mean by that? If I have 1 over, let's say we're not working with numbers in this instance now, we're working with x. So if this is x to the power of 2, I can change this to a negative number. There is a delay on my laptop when I write, and this will be x to the power of negative 2. So it means 1 over is the same as a negative. The negative power will be 1 over. So if it's x to the power negative 1, let's say, for example, we don't have this. And we have x to the power negative 1. If we have this as our final answer, is not complete because sometimes they might want you to change it into this format. And when we change it to that format, it will just be 1 over x. So it means if they give you 1 over x, you can write it as x to the power of negative 1, because on here it's power over 1. You will have exercises that looks like this. So that is why I am repeating it so often, so that you can understand when you do those exercises. The last one from the note, it says, any number to the power of a fraction, you can write it as the root of that number. What do we mean by that? If I will start with the fraction. If I have a to the power of half, I can write this as the root. So the value of the denominator on the fraction comes in front of the root, and the root is represented by 1 over is your caravan, and your a will go underneath the caravan. What if I have what? A over So let's say we get the following. Let's say I have 8/6. Therefore, I can write it as √6 of A, and vice versa. So it means if I'm given the root of 6, I can write it as A to the power of that value. So what happens if this was a number? If it was a number, you will solve the root, or you will solve the power of a fraction for that number. Let's look at the actual example, which looks almost like it's complicated, but it is not. It's simple. And let me look at your next exercise, how it looks. So since I like you guys for sacrificing yourselves, we'll swap. You will answer example. I will do your exercise. So this exercise will be my example. So to differentiate this function, remember our rule. Differentiating a constant is equals to 0. Remember that. Any number without a power is the same as to the power of 1. So if I look at this, this is to the power of 1. So I can just write 1 there. It's to the power of 1. The other thing, since this is a sum, the same way we can differentiate each function on its own. So differentiating y x will be to differentiate the first one. Remember, this is a constant, therefore it will be 0. Plus, to differentiate this, we multiply with what is in the power. 5 multiplied by 1. Just give it some time. It's delay x. I will run out of space. Okay, x didn't come. X times x minus, we need to differentiate this, will be 5/2 times 2 in the power. Remember, what am I doing wrong here? Let's go back. There is something that I am doing wrong. I am not subtracting what is in the power. I need to do this on a clean slate. So let's, because I'm running out of space. So minus 7 plus 5x minus 5/2 x squared minus 3x to the power of 4. I'm gonna go into a black screen and I will try and do this on a black screen. So let's y right now, because sorry about that. Apologies for that. Okay, so we have our, for some reason, it's fighting with me. It's fine. It doesn't want me to write 5/7 minus 7 plus 5x minus 5 over 2 x squared minus 3 to the power of 4. To differentiate, we're going to say y hat is equals to differentiate, and the constant is equals to 0 plus. Remember, this is to the power of 1. We're going to say 5 multiplied by 1 times x, and 1 minus 1 because we need to 1 minus 5 over 2 times 2 x 2 minus 1 minus 3 times 4 x to the power of 4 minus 1. Lucky enough, I didn't get out of this slide. And y hat differentiation. The first one is the 0. I don't have to repeat 5 times 1. It's 5 x to the power of 0 because 1 minus. Remember this, I can write it as 2 over 1. Any number over 1. Remember with multiplication, we cancel 2 and 2 will cancel out. 5 over 1 equals 5. And x 2 minus 1 is 1 minus 3 times 4 is 12 x to the power of 3. And y hat 5 times x to the power of 0 is equal to 1. So this will be equal to 1. Remember, any number to the power of 0 is equal to 1 minus 5 times x because we want to write the power of 1 again minus 12 x cubed. So the final answer, we rewrite it correctly fine. 5 minus 5x minus 12x cubed. Any questions? I can't see the chat because I moved it and it's covering the whole screen. So please unmute yourselves and let me know if you have any questions. If I move from this screen, it will disappear. So do you have any question? Am I alone in this room? Okay.
Hi, Lizzie.
Yes. No questions.
Hi, Lizzie.
Yes.
Can you please just repeat step number 3 for me? Especially la part 5 over 2 times 2.
You
How
mean
did
that
you get
one?
that? Yes. And then upper step 3, how did you get that?
This part, which is minus
Yes.
5 over 2. If we multiply we multiply with 2, and we can write it as 2 over 1 because we're going to work with fraction to the power of x 2 minus 1. So since we are doing a multiplication, we can say 2 cancels out with 2. Remember that. And then it will be 5 multiplied. So 2 goes 1 time into that, and it goes 1 time into that. So 2 times 2 will be equals to 1. So the answer here will just be the same as x. You must remember the x and the 2, so it will be x to the power 2 minus 1 is 1. And the answer here, we can write it as 5x to the power of 1, which is what I have here. So this step, it is this step. And the next step will be how I answered it in this way. Is it clear? Do you now understand?
Yes, Lizzie, thank you.
Thank you. Okay, so looking at our answer, do you still remember what the answer? The answer that we found for the differentiated function was 5x was 5 minus 5x minus 12x cubed. You still remember that. And that will give us option number 2. So with that, this is your exercise to do. And with this exercise, let me check the time. What time is it? It's 17:43, so do the exercise and then you can also take your 10 minutes break during the exercise. We will come back exactly at 6 o'clock, but 6 o'clock will be too far, so that we can finish early as well. So it's 10:43. Let's come back at 17:53. We'll come back at 17:53, but you can continue and do the exercise in between. Are we back? Are
Yes,
we ready?
Yes, we're ready.
Okay, so I can see here, Rodney already posted the feedback to say it's 2. And Tristan, you also said, oh, somebody liked your answers. Okay, who wants to do this exercise with me now? Since you all have the answers, we're going to help those who are going to watch the video to show them how we work it out. Anybody? Someone? Nobody. Ha, guys, I give up. Okay. I will do it myself since nobody wants to talk to me. I hope in the exam you don't expect me to go and answer your exam questions as well. Okay, so remember to differentiate. We multiply with what is in the power, which is 12 times 3 to the power. Actually, I like using brackets because the multiplication, sometimes they look like an X. So let's use brackets. 12 times 3, x, 3 to the power minus 1, minus 3 times 2, x to the power of 2 minus 1, and plus like now my pen is frozen again, plus x is the same as to the power of 1, so it will be 1 times x to the power of 1 minus 1, and 14 will be minus 0. 14 will be minus 0. Minus 0. Then what do we do? 12 times 3. What is 12 times 3? Is equals to 36. 36 x 3 minus 1 is 2 minus 3 times 2, 6 x 2 to the power 2, x to the power 2 minus 1 is 1 plus x to the power of 0, because 1 times x is x, to the power of 1 minus 1 is 0, and the other one is minus, so I don't have to write it. To clean this up, we can just finalize this. It will be 36 x to the power of 2 minus 6x and x to the power of 0, any value to the power of 0 is equal to 1. And the answer that we have is option 2, as you all heard it as option 2. And with that, it completes of our session. Since we took already the break that we needed, we will continue and do exercises. It will be very helpful if you guys can participate. Remember, we did this as an example. I'm not going to repeat this. So now let's look at how we differentiate and calculate the marginal profit and the marginal cost. And this will take us to more exercises as well. So differentiating profit function or cost function, we will be calculating what we call the marginal cost or the marginal profit. And how do we do that? I'm not going to dwell too much onto the content because we know that when we are differentiating, we're calculating the slope. So to differentiate a marginal profit or a profit function, we're calculating what we call a marginal profit, which is just the slope of a profit function. The same way with the marginal cost, it will be the slope of the cost function. So how do we do that? How do we differentiate that? So for example, if we have to calculate or differentiate the profit function, we know that we will be calculating what we call the marginal profit. So this is a profit function. Profit function says revenue minus cost. It will give you profit. Whatever is left will be what you have profit, or what is your profit. To differentiate, we just differentiate the profit function. Therefore, it means we will be differentiating the revenue function and also will be differentiating the cost function. So let's say we have, before we say we have, so let's say our profit function is made up of 2x. We don't know how many number of products we sold, minus the cost, which will be equivalent to the cost minus the cost of 2 rand. So the cost was 2 rand of the revenue that we're making out of 2 times the number of products we sold. When we differentiate this profit function, we apply the same differentiation rule that we applied previously. X, it will be x to the power of 1. We multiply with what is in the power. So 2 times 1 is 2. We subtract 1 from the power. So it will be 1 minus 1 will be x to the power of 0 minus differentiating a constant will be equals to 0. And this okay. And that will be equals to 2 times 1, because that will be x to the power of 0 will be equals to 1. Therefore, the profit that we would have made will just be 2 rand. For this, the slope will just be 2 rand. So for every additional 2 unit you produce or you sell, you have a 2 rand profit made out of that. And that is the profit function. So if we want to maximize the profit, then our marginal profit function, we can put it to be equals to 0. And in that way, we will be calculating the maximum profit that we will have. Okay, let's look at how we do more of the exercises on profit. So this is our profit function. It's the total profit and it's given by this function. When we sell X item, we need to find the marginal profit of marginal profit. We say the profit function, differentiation of the profit function. This is a constant, will be equals to 0 plus 1 times 100 will be 100. X to the power 1 minus 1 minus 5 times 2x to the power 2 minus 1. Oh, my 2 minus 1 is written wrong now. 2 minus 1. 0, we don't have to repeat, so it will be 100 x to the power of minus 5 times 2 is 10 x 2 minus 1 is 1. And to finish off this, we know that x to the power of 0 will be 1. So this will just be 100 minus 10x. And we can rewrite this whole function by putting the 10x in front so that it looks like a linear function. We will say our profit function or our marginal profit is minus 10x, because we can rewrite this plus 100, which makes it option number 2. And that's how we calculate the marginal profits. Sometimes in your module, you are expected also to interpret what does it mean. For example, we can be asked, you can be asked to find the marginal profit if we increase the number of toys we sell by 20. The value inside the bracket, remember, if it was a marginal profit, that would have been PX. Remember that. So it means where we see, we need to replace it by 20. So if this is our marginal profit and they're asking us to find and interpret this, we're going to substitute into our marginal profit function 30 minus our X will be represented by 20 divided by 5. Sorry, Nancy didn't write. He's still busy thinking. And my computer froze. Can you still guys hear me? There's nothing I can do right now. Are you still able to see the presentation? I think it closed. I will reopen it. Did you guys hear me?
Yes, we can hear you and we can still see the presentation.
Okay, good, because on my side it closed. I just need to reopen it and share it again. I don't know what's happening with my PC today. It's on boycott, on strike. When it comes to non-QMI questions, hey, you guys, you are killing me. You respond very quick. I hope we can have this kind of discussions when we're dealing with QMI as well. Okay, so I'm sharing. There we go. Okay, I will have to start again. Problem is on my side. It went blank again. Are you still seeing the presentation?
No, we can't see the presentation. Oh wait, yes, it.
Okay, you know what? And now it's gone again. My
Yes,
bad. So today I'm having challenges with my PC. Let's see again, because there's nothing that I am doing from my side. It just keeps on freezing. I cannot even write on it. I will try for the last time. So if you have any question for now, so we are all introverts. I'm also an introvert, but I am speaking to you guys. I am not hiding away. I am pouring my heart out. Okay, let's try for the last time. If it doesn't work, I will open a work with exercises from the past, because I think my PC is also making a lot of noise, so I don't know what is wrong with it. But we almost done with explaining some of this. So we should be doing other exercises just now. Again. Okay, so today it's that day where my PC just decides not to work with me. And there is now my team is black.
Elizabeth, I can't hear you.
I apologize for that as well. So today was not the day. Okay. Now what went wrong here? Wait. Why is it giving me discard? Okay. We're gonna go back. Okay, let's try for the last time now. I seriously don't know what's happening with my PC today. Maybe I must restart it after this. Okay, so going back, where we see X on the marginal profit, 20. I cannot write on the slides. Let's see what's wrong now. Okay, it's one problem after the other. So marginal profit, 30 minus, we split it with CX with 20 divided by 5. 30 minus 20 divided by 5 is 4. Okay. And 30 minus 4 is equal to 26. And the question was, interpret the results. And the question is, interpret the results. And to interpret the results, we just say, when 20 motorcycles are produced, it will yield an increase of 26 Rand per motorcycle in profit. Or we can also say, in other words, the same thing, but in this way. For every additional motorcycle that is produced, it will yield a 26 Rand in profit. Remember, this is a slope. So if we can go back to the slope, which okay, I'm going to draw it because it doesn't allow me to, it keeps on freezing. If you look at the slope function, remember we calculate the change between the 2 points. And that change is brought in by the changes in different points. So when we move from one point to the other, it's either going to increase or it's going to show a decrease. And that is what the slope means. So we interpret it in two different ways. We interpret it in this manner to say, for every 20 motorcycle, which is a direct interpretation when you look at it in this manner. For every 20 motorcycle you are producing, you're going to have an increase of 26 Rand in the profit. Alternatively, we can say, for every additional motorcycle we produce, one additional motorcycle will produce, it will yield an increase of 26 Rand in profit, regardless of how many we are producing, but for that additional, one additional. So even if it's 20 or it's 30, as long as it's going to be an addition to the number that was there before, it will yield an increase. Or if it was a negative value, it will yield a decrease. Okay, so conclude with that. Then it's time for more exercises. This is your first exercise. Suppose this is your cost function. Calculate the marginal profit. So differentiate that cost function. And when you are done, please let me know so that I can see how many people are done. and we can start the recap in the feedback. Are you still busy?
I'm finished.
Thank you. Others, are you still busy? Okay. Okay. So Brian and Tristan, you said you got the same answer. Okay, who wants to do the exercise with me, please? Nobody still? Oh, seriously, you don't want to talk to me? Okay, great. Jack, I hear that, I know that you are in the session. You can see that this UNISA student don't want to talk to me, so I don't. I hope this is still the exercise that you were supposed to do. Oh, okay, sorry about that. Other one. So to differentiate is, sorry, when I click on the We're going to differentiate the cost function by multiplying with what is in the power, which is equals to 2, and say x, and subtract 1 from the power, plus 5x, it's the same as to the power of 1, so it will be 5 times 1, x, and to differentiate a constant, plus differentiating a constant will be equals to 0. Since this is 2 over 1, we can treat it as a multiplication of fraction, and we can simplify it further, or we can multiply what is at the top with what is at the top. Otherwise, we can say 2 goes 1 time into 2, and it goes 5 times into 10. And when we solve this, we will have our differentiated function of 1 times 1 is 1, divided by 5 times 1 is 5. And x to the power 2 minus 1 is 1, plus 5 times 1 is 5. And what did I do here wrong? I didn't put 1 minus 1, so that will be x to the power of 0. And this is plus 0, and we do nothing today. And this will be, if we clean it up, 1 over 5x plus x to the power of 0 is 1. So 1 times 5 is 5. And the answer that we will have here will be option number 1. Let's see, what option did you guys choose? You said it's 1. And that will be the option we choose. The second question, I'm going to remove this. Your next question is to interpret if we have to increase or add additional 1,000 kilograms of steel, what will be the marginal cost, and interpret the results afterwards. So you need to choose which one of this statement will represent that marginal cost. And when you are done, please let me know. Don't wait long. Are we done?
I'm done, Elizabeth.
Ah, guys. So you don't even talk to me, even when you are done. I give up on you guys. I give up. I give up.
I didn't say anything because I was confused of 2 and 3, but I think it's 3 now. So
Okay.
I did reread it. That's why.
Remember, it's not a direct translation as well. So, and when you are stuck, please don't hesitate to ask.
Okay.
So today you just went mute on me. It's fine. Okay, so they say we must increase or calculate the marginal cost of 1,000 and interpret the results. So since we know what our marginal profit function is, we just substitute where we see X, we're going to put 1,000. So it means it will be 1/5 times 1,000 plus 5, which is 200 plus 5, which is equals to 205. And since this is a marginal cost of 205 and this is a slope, we can safely ignore the bottom ones regardless, because those are just straightforward interpretation. It doesn't tell us about the slope. Remember, the slope tells you the change in the value. If I move from this value to that value, what is my slope? That's what it is telling me. So it means for one additional, every time I move, I'm adding additional 1, I'm adding additional 1. So depending, if I move there, I can calculate the slope of that place. And if I move there, I can also calculate the slope. So it's for every additional unit, what will be the cost of producing that. So number 1, it says the cost of producing 1 additional kilogram of 1,000 kilograms have been produced is 1,200. We know that that will not be correct, which makes number 2 the correct one, which says the cost of producing 1 additional kilogram of steel after 1,000 kilograms have been produced, it will be 205, because we're calculating the slope. Any question? Then we can do, maybe we can slot in 2 more exercises before it's time's up. That's gonna give you one complicated one so that you can look at that, but I will give you the hint on how to answer this. So here they give you the cost function and they also give you the revenue function. And they're asking you to find the profit function. So in your mind, you need to know what the profit function looks like. What will be the profit function? We know what the profit function is. I'm not solving it for you. You will have to solve it. I'm just writing the formula for the profit function. Remember, your profit function is revenue minus cost. So based on what you have, find the profit function. When you are done, please let me know that you are done. If you don't know how to answer the question, also talk to me.
I'm done.
Thank you. So, Tristan, you have the answer.
My answer is 3.
Okay. Let's see if your answer is right. Unless if you want to talk to me in the last few minutes. So
Okay.
we substitute. Oh, are you? Yes. Thank you.
Okay, I'll give it a go. So you substitute the R. Oh, I don't
Yes,
like
the
doing
revenue.
this. The
Yes.
revenue minus
Mm-hmm.
the cost.
Mm-hmm. So our revenue is
So the
8x.
revenue is 8x minus x to the power 2 minus 2x plus 5.
So you need to put it into bracket because there is a minus there, and this is to replace the whole of the CX.
Oh,
So
shoot.
it's 2x
Oh,
plus 5 because it needs to go into bracket because it's the whole thing is CX, not only the one part. So all of it. Now we need to remove the bracket.
and my answer is wrong.
It's fine. Let's work it out. So it's
Okay,
8x minus x squared. And when we remove the bracket, negative times positive will be my negative. So it's minus 2x and minus times negative times positive, it becomes negative, and this will be minus 5. Oh no, this is not a differentiation. Why am I differentiating? This is our profit function. And we can rewrite this profit function because it's not the end, since we have two, like 8x and 2x. They are the same. So if we rewrite this, we will have minus x squared, 8x plus minus 2x will be plus 6x minus 5. I hope it will write. And the answer will be
D.
option number 4. The next question they might ask, because this might be question number 24, and then the question number 25 might come up, and it might say.
Hi, Lizzie.
Yes.
Lizzie, can you hear me?
Yes, I can hear you.
Hi, so it's Brian here. So I got option number 2, and I did it differently. And the cost function and the revenue function, I did it individually. I got the cost function equals to 2, and the revenue function equals to 8 minus 2x. And then I took it into the profit function. And then it equaled me to minus 2x plus 6.
Nope. Yeah, but remember here, they're not asking you to differentiate. They were asking you to find the profit function.
Okay.
They were just asking you to find the profit function, not the marginal profit. So you were supposed to just take the cost function and the revenue function so that you can create a profit function.
Okay.
So what you did,
Okay, I
you
understand.
differentiated
Yeah.
first.
Yeah. Yes.
So you must be very careful and read the question correctly. As long as they are not asking you for the marginal profit, then it means you must create a profit function without differentiating. Okay, so
Okay, thank you.
Yes, now the next question is going to ask you to differentiate. So I need to remove the ink now. Let's do that. So we know that this was our answer. So knowing that was your profit function, what will be the amount of units that needs to be produced in order to maximize the profit? And remember, the answer is in thousands. Why the answer is in thousands? The units are produced in thousands. So what do you need to do? I'm sorry, my PC is acting up. As you can see right now, it's going up and down. What you need to do right now is, the first step that you need to do is to differentiate my pen got stuck now. Differentiate this profit function. Differentiate the profit function. Differentiate the profit function. After you have differentiated the profit function, the next step that you need to do is to maximize profit. Remember, your differentiated profit function should be made equals to 0. So once you differentiate your profit function, you can put it equals to 0 and replace the differentiated profit function to be equals to 0 and solve for x. So you make it equals to 0 and you solve for x. Step number 3, which will be the last step, you go into multiply. Multiply the answer you see by 1,000. You multiply the answer by 1,000. That's my bad. That's my screen acting up. I hope you are able to see what is happening there. So solve for x. Once you're done, you multiply your answer that you will get in 2 by 1,000. Then it will give you your maximum profit. And that will take us to the end of this session. Are we done? Should be quick.
I'm done.
And what is your answer?
My answer is 3,000. I mean, number 4. But I'm not sure if it's right.
Okay, let's see. So we need to differentiate this profit function to differentiate just give me some sec because it do you still see the presentation? It bumped out on me again. I can't see it. Okay. As long as you I'm posting right. Okay. Our differentiation of this, we're going to multiply minus 2 because it's minus. So we multiply with 2x and we subtract 1 from the top plus 6 times 1 is 6 and subtract 1 from the top. And to differentiate, the last part will be equals to 0 because it's a constant. And minus 2 minus 1 is x, and x to the power of 0 plus 6x to the power of 0, and we can ignore the 0 there. And the answer here will be minus 2x plus 6 because x to the power of 0 is equals to 1. Now, remember, this is our marginal profit. To maximize our profit, step number 2, it says to maximize our profit, we can make our profit, marginal profit to be equals to 0. We are applying step number 2. And solve for x. So to solve for x, we need to take this 2x to the other side. Taking 2x to the other side, it becomes positive because it's negative 6. And to get rid of 2, we divide by 2 both sides. And therefore, we end up this side, 2 cancels out. We end up with x, and 2 can go 3 times into 6. And the last step, it says, multiply your answer by 1,000. Then we multiply our answer by 1,000 and we get 3,000. Never sell yourself short. You did everything right. And that's how you differentiate. You can go through other past exam papers and find more exercises relating to this. I had one exercise, but okay, this we did. I don't have to go back again. And I have this other complex exercise that is there. So if you have any question, feel free to ask now. Remember with the past that we did the note, you should be able to answer this question or differentiate that question. With that, I am going to collect the quiz and summarize what you have learned today. You've learned how to apply the basic rules of differentiation. You've learned how to calculate the marginal cost if you are given the cost function, and also how to calculate the marginal profit if you are given the profit function, or you can also derive a profit function. other thing, you've learned how to interpret the marginal profit. And if there are any questions, now is that time where you can ask. Otherwise, if there are no questions, I just want to check if Claudine did put the feedback form on the chat. If not, just give me a sec. I will post the feedback form for you to complete before the session, before you go. Just want to check the chat. Yes, she did, but I will just copy the link again and paste it there. Please complete the feedback form. And if there are no questions, thank you. I will see you on Monday.
I have a question.
Yes.
Not actually a question, but can you put the complex question back onto the screen? I actually want to try and do it.
And if you have the answer or you're struggling, remember you can always talk to me on the WhatsApp group.
Okay.
If I cannot go back to, is it on the question? Still not. Hey, my PC today is dealing with me. Sorry. There we go.
Thank you.
Remember to apply those rules that we did. So to give you the hint, before you do the differentiation, you will need to take, oh, come on. Okay, my PC is frozen. Okay, so you will, come on, wait with me. So for this, remember, you will write it as power over half. So that will still remain, but everything will be to the power of 1/4. And then you will need to solve what is inside here. And to do that, you will say 3 multiplied by 1, which will give you 3g/4. And then you will use it there. And then it will be 2 times g to the power 3/4. That is only doing that part. Remember, there's still a multiply by 2. Doing this part, I'm talking about only that part. So this is that part. So the answer, you can go back and substitute it back, doing only that part, which is 1/4g3. Since everything is underneath that 1/, so you're going to take it, all of it, and this will be the same as 4g2 minus 3. And that will be that.
Thank you.
Oh, sorry, I forgot. This should also be -1 there because it's the same thing. So if that will be 1/4g, 1/g3 is the same because they are multiplying. So we can write it as 1/4g3. So 1 times 1 will be 1. So it will be 4 to the power of -1 g to the power of -3 because g is to the power of 3. And it will be -1. And you can take this and substitute it back into that and differentiate after that. And then you will take this and take it back into there and differentiate. And that's the only complex thing you can do from here. Okay, all right. Thank you, guys. Thank you for coming through.
Thank you.
And if there is no other question, then we can call it